I was like really like hankering for static typing, and TypeScript was offering exactly that. So I got very excited like early on. And I became involved in actually like a number of open source projects related to TypeScript. So definitely typed, which like type definitions are the interop between JavaScript and TypeScript, and definitely typed is the place that you go to find those essentially. Like they power like the interop between the two. And like definitely typed is actually like a massive project now, and I think it's, last time I checked, it was something like the 8th most active project on GitHub. But in the early days, it wasn't too many people involved. And also, I did a number of projects related to TypeScript and Webpack together. So like TS Loader and FortTS Checker Webpack plugin are both things that kind of like marry together the experience of developing in TypeScript and Webpack, so that you can use both and be happy. So yeah, as you can tell, I really love TypeScript, and that's what we're going to talk about today. Like all good talks, this one began with a tweet, or rather, it began with like an automated email. So I subscribe to loads of automated to loads of issues and pull requests inside GitHub, and get automated emails off the back of that. And on one evening, I received an automated email, and it was telling me that a pull request had just closed an issue that had been around since like November 2016. And it was, as it so happened, it had been closed by Anders Hallsberg. It was kind of like my coding hero. So I was kind of interested in this, and I opened it up, and it was this really exciting feature. TypeScript now had indirect type narrowing via a const, which is a mouthful. I get that, and we're going to dig into that over the course of this talk. But this is something really exciting, and I tweeted about it, and other people like really excited at the same time. So this is a guy called Zer, and I'm sure I'm pronouncing that wrong. So if he ever should hear this, like I apologize in advance. But he was saying, "Oh damn, this is amazing! Like lack of type narrowing with const, maybe repeat code or avoid helpfully named consts like too many times." So you can see this feature is like inherently linked to like the readability of code, and yeah, people were excited about it with good reason. So we're going to look into this over the course of this talk, and we're going to sort of like go back a little bit, and we're going to go forwards as well. So in the beginning, TypeScript was void and any. And what I mean by that is that TypeScript was, the language today is incredibly powerful. The type system is just, it's amazing, some of the things that you can do in there. And in fact, if you want to see some of the kung fu that can be achieved in the type system, it's worth looking up some of Josh Goldberg's talks, because he really does demonstrate what's possible. But in the early days, in 2012, when TypeScript 0.8 like first was announced, it was very sort of primitive, and the things that you were getting from TypeScript were like they were more powerful than linting, but they weren't like leaps and bounds more powerful. And back in the early days, oftentimes you couldn't really define the thing that you were trying to define with types. You had to just use this any type, which is basically like throwing your hands up and saying, I can't do better right now. Now the mission, my mission, yours too, I hope, is to write type-safe code that is readable. And there's always been kind of a tension in TypeScript, I think, between being able to write type-safe code and trying to write readable code. And ideally, you can do like both of these, and actually these days you can totally achieve that. And we're going to like look at how over time writing a piece of code in TypeScript has changed depending upon what was forwarded to you, what was possible within the context of the language. And we're going to write a super simple function, an add function. And as you may guess, this add function takes the things that are passed to it, adds them together, and gives you a total. So here we're passing an array of numbers, and excitingly, sort of stringly numbers, strings which contain numbers therein. And it's going to take this, hopefully this example here, when it exists, will take 1, 7, 3, 9, and come back with the princely sum of 20. So we're going to start with vanilla JavaScript. Remember, it's 2012. And here's our add function. It takes the total, it iterates over what comes in, it checks the type of the thing to add that it's looking at, and if it's a string, it coerces it to a number and adds it to the total. And if it's a number, then it just adds it to the total. And if it's not either of those, it's, hey, this is not what I was looking for, and throws an error. And this will hopefully give us the total that we would hope. And we're going to test this out right now. We're going to use this a bunch of times over the course in the TypeScript playground. TypeScript Playground is a place that you can go to where you can just experiment and write TypeScript without having needed to install an editor or the like packages or anything like that. You can just experiment, like write simple things here, like just try them out, see what it's like. And this has always been around, by the way, since the early days of TypeScript, but it's got like leaps and bounds better in the last couple of years, mainly due to the work of like the amazing like Author Throx, who's part of the team, and he's just done incredible things. And in fact, one of the things that I like so much is that there's now the ability to try out different languages, sorry, not different languages, different versions of the language within the playground. Unfortunately, it only goes back to 3.3 at the moment. Possibly they could change in the future, we don't know. So you'll have to imagine when we're looking at TypeScript 0.8 and other versions that we're actually looking at those versions in here, but we can still do this from the purposes of demonstration, I think. So here's our add function, and this is just like vanilla JavaScript at this point. And you can see we've got a total here, and we're iterating over, as we said. We're not getting a ton from this at the moment from TypeScript, but let's just test that it works. So we're going to call this function. We're going to pass it an array of things. What was it? 1, 3, something like 7 and 9. My values are something like that. And if I hit the run button up here, that should execute this. Yeah, 20. That's exactly the number that we would expect and want. So this is working. But TypeScript's not giving us a great deal right now. So if I chop out this and try and pass it like an object, or a Boolean, neither of those are like valid things to send along, it's not going to complain. So what I can do is I can add a type definition to this thing here, and I'm going to say any, it's some kind of type, and it's an array of any. I'm going to say the return type is number. So it's only going to allow in arrays now, an array of any sort of type, but it's only going to allow an array. So if I try to do what I did a second ago, chop this out, send in an object, TypeScript's complaining, and that's great. So we're getting value from TypeScript already with TypeScript 0.8. So now let's dive back. Now we've moved on to 2015 and TypeScript 1.4. So TypeScript 1.4 was like actually a massive release. In fact, there's kind of a history in TypeScript land of like really significant releases which don't have like a major point number on them, but like really important features arrive with them. And TypeScript 1.4 is like exactly an example of that. And so there's 3 things that inside this that were exciting: union types, type aliases, and type guards. And we'll dig into those now. So the first thing is union types. So you see at the top here, we've got any, and it goes to a number or string. Union types, what they allowed us to do was to say, where in the past we would have had any, we can be more specific. So actually, it was never really like an any type. We knew it was always going to be a string or a number that was passed. So that's what we wanted to restrict our input values to. And as of TypeScript 1.4, like we could do that. We had the ability to say, rather than any, we could say number or string. So inside here, you can see number or string. And so this is now going to only accept numbers or strings if we pass them through. So we're going to open this up in the playground once more. And here's our code down here. And you can see we've got 1.7 thing. And if I try and pass like, say, false, it's going to complain because false is not a number or a string. If I try and pass an object, again, it's going to shout at me. And this is delightful. We're hardening up the type safety here. We have more type safe code as a consequence. And in fact, we no longer need this kind of like this else branch here because we're already restricting what can execute inside the context of this function by the signature up here. So we're reducing the amount of code that we have, and that makes our code more readable as a consequence. So we're improving type safety and we're improving readability, which is wonderful. The next thing was type aliases and type guards. And type aliases is kind of like a sister feature, if you like, to union types. So type aliases, I think of them as like variable names for types. And what they allow you to do is where you've got like a type or a complex type of some kind, you can give it a nice name. So here we've got number or string, which is a little bit sort of not so great on the eyes. And we can just give it a great name like number or string. We can explicitly use that inside here. So if we compare that to how it looked previously with the number or string, you see we've got this parens going on and this or, and it's kind of hard to just, drink in the code as you're looking at it. Whereas this is, it's just easier on the eye. Like this is, yeah, so much more acceptable. And the thing that came with that was type guards. So if you remember earlier on, we were talking about the if type of thing to add things. So this is a runtime feature of JavaScript. As this code's executing, every time it goes around here, it's looking at the type of thing to add, and it's saying, okay, well, if this thing is a string, we're going to go through here, and otherwise we're going to go through here. Like it's making a choice. It's branching off the back of that. So this is a runtime JavaScript concern. But as of TypeScript 1.4, TypeScript became kind of like type aware, as it were, of what this was doing. So it knew that a consequence of like running through this was that inside here, thing to add could only be a string. And so if you look actually here at the hover, it's at this point here where it's being evaluated, thing to add has the type number or string, because it could be both. And if we go inside the branch here, it's got the type string because we've evaluated it's definitely a string. If we bounce down to here, it's the type number. So like this is tremendous. We've got TypeScript understanding like what's happening in our program and making choices, like narrowing the types that we can write against off the back of that, which is great. So there's like, these are the major features that were with TypeScript 1.4, but it emerged somewhat quickly that there was a fly in the ointment. And what we're going to do is demonstrate that fly. So we this is not bad code. This is good. This is somewhat readable, but like I don't love line 6. Line 6 is like you've got to kind of like scan it and then you work out what it's doing. It's like, okay, it's cool, right? I get it. It's branching off the back of that. And it's not telling me what it's doing. You have to sort of like you're understanding like what it's achieving, and then you're having to do that in your head. And I would rather sort of break that out here and drop down to here. So const should coerce to number and put that in like that and drop this in here like this. So what we've done here, we've separated the type out here. Sorry, we've separated the type narrowing out here into a meaningful function name. And sorry, a meaningful variable name, sorry. And then we've used it in our branching. But suddenly, things have gone awry. So if we look here, we look at thing to add, it's number or string. If we look at thing to add, it's number or string. We're no longer type narrowing. So TypeScript, like it doesn't remember that it's done type narrowing at this point here when it gets to here. So it has done type narrowing, but it's not flowing that on to the rest of the code as a consequence. And this is the feature that arrived with TypeScript 4.4. So let's take a look at that. So TypeScript 4.4, and man, every time I think about it, so I have to read it because the name is not pithy. Control flow analysis of alias conditions and discriminants. Yeah, not wordy, but when you see like what it is, it totally makes sense. So we're going to look at type narrowing with a const, type narrowing a discriminated union, and maybe one other extra thing as well. So type narrowing with a const, and this is kind of what we were talking about a second ago. So let's open that up. I'm going to close some of these old tabs here. So here's our TypeScript playground, and inside here you can see we've got the should coerce to number, and we're still on TypeScript 3.3, and everything's sad. Still complaining and moaning, and it would be right the way up to TypeScript 4.3 as well. So I've selected TypeScript 4.3. Still, this is a problem. We still have the same errors showing up. Everything's nothing's changed. It's been like this for 5 years, but now TypeScript 4.4. The world has shifted. And now, if you look, we don't have errors. And if I hover over this here, it's saying string and it's saying number. is now type narrowing. So this is the exciting thing that lands with TypeScript 4.4. We're type narrowing and we're remembering that. So we're doing it at the point of this const here. And by the way, it is significant that it's const and not say let. If you do let, you get the same errors as before, and that's intentional, right? But that's because const can't be reassigned. Let can be, and so this thing here is taking account of that. Yeah, so now we have the type narrowing that we would hope for, which is tremendous. Like it's remembering it. TypeScript's like holding on to that and carrying it on. And then we've looked at it with primitives so far. Now what we're going to look at is a discriminated union. So discriminated unions and type narrowing therein. In fact, let's pause here for a second. Rather than having primitive types like number or string, we're now going to have possible object types. So there's two possible objects here, and they've got a common property, a discriminant property called what am I. One possible value is integer, and if it's integer, then the data property that sits alongside it takes the value number. And if the property what am I takes the value text, then data is going to be a string. So you can see this is the same thing, but we just kind of like objectified it, if you like. And the code that we pass to it is obviously sort of like slightly more verbose, but it's the same deal, right? We're doing the same kind of thing. So let's take a look at that. So we fire open the TypeScript playground, and here we are. And inside here, we're dealing with our object, and rather than just like dealing with the object by itself, we're dotting off the object and looking at what am I to do the type narrowing, and then we're dotting off the object to get the data property. And as you can see, we've got string here, and we've got number here. So yeah, this is working just as we would hope. But let's see if we can increase the readability like one more time. And personally, a thing that I love is destructuring. So we're going to destructure our thing to add. Whoops. And we're going to take out the data property and the what am I property. And what we can do now is we can chop off. Whoop, we can chop off the thing to add here, and we're still type narrowing, as you can see. Still string, still number. And unfortunately, though, if we try and chop off the thing to add here, it doesn't do what we would hope. So this is a known issue with the feature at the moment. So at the moment that you break apart data and what am I, the moment you destructure, you're separating the relationship in TypeScript's head from these two things here. And so when it gets down here, it doesn't remember that data was related to what am I. And this is possibly something that will be remedied in a future release, but it's something to bear in mind right now. It's not the end of the world, because you can still just like dot off the object, and you still have support for discriminated unions. You just don't have it for all cases of destructuring. But it's yeah, it's just worth knowing that extra thing, I guess. So now we're into bonus points territory. And there's probably something that's been in the back of like some of the people on the call's heads, like the whole way through the thing, which is like, he's lying. Like this function, like you could send something to it which isn't a stringly number, and it would fall over, and there's nothing to stop him. And those people, you can feel glad, because you're totally right. And we can solve that using a feature called template literal strings. And I've just got a little explanation here, which I stole from the TypeScript handbook, which kind of explains what they are. So template literal strings are kind of like template strings in JavaScript, but used in the type position. And this is actually quite a good example. So you can see here, we've defined this type here called world. And underneath it, we define a type called greeting. And we've got in the type position sort of the backticks, which are familiar to you if you're doing like string literals. And inside there, the dollar open brackets, and we inject that type into this here. And when you look at what that results in, it results in hello world, which kind of makes sense. Like it's exactly what you think it would be. But like world can be like so much more, like there's so many more possibilities that you can put in there. And that's kind of what we can use to solve our case. So what we want is strings that are only digits. Like we don't want to allow through like just like random text. Like we want to defend against that like hard. And we can do that using template literal types. So here we can define a type called string with digits only, which is just backticks, open parens, as it were, and not parens, open curly braces, and number. And what that means is that anything that a number could be coerced to is like a valid type value in this position here. And then we can just inject that into our number or string type. And let's take a look at what that looks like inside the playground. And here it is. Here's our string with digits only type here. And you can see down, it's more interesting actually if we chop this out for a second and just revert this back to be number or string. So down here, like, this is not allowed. This shouldn't be allowed, but right now, it is. TypeScript isn't stopping us. But if we take our string with digits only, we drop that in here, suddenly this lights up red. I'm like, that's delightful. That's the red of happiness, right? This is telling us that we made like a big mistake and we need to fix it. And now, like, it's only allowing through the stringly numbers, which is tremendous. This is, we've really hardened up like where we've ended up. So this is kind of like our final code actually. Here we have code that is like rock solid, type safe, and it's quite expressive. It like kind of tells you what it's doing. So we're balancing really well those two tensions. It is readable. It is really type safe. Like this is exactly what we're sort of like desiring and aiming for. As I was writing this talk, I got thinking about like other things in the TypeScript space, which are kind of like this, like other areas where there's kind of like type narrowing that doesn't happen. And this was one thing that occurred to me. So you may be aware of maps in JavaScript, and they have like a fairly lovely API. This has and this get. They always they always has. They always have a has, and they always have a get. And has allows you to check whether something is inside a map, and then get allows you to acquire it. And you can see from this code here, we're creating a map of addresses, and here's me, and here's London, where I reside. And we check whether it exists in here. And just from looking at this code, like we all know that that this is true. We're going to branch into here, and when we call addresses.get, it comes back with string or undefined. Whereas we know from looking at this code that actually like that can't be the case. It's always going to be just like address string. And so yeah, TypeScript's kind of like it's wrong about this, and this is possibly like an area in the future where more things might happen like this. I can think of possible reasons why this is like it, in the sense that like maps are mutable and this could be changed. And I don't know, you'd have to keep track, I guess, of every call to like addresses from here to here to make sure that there've been no other interventions with it. And like it might be that this is intentionally sort of like not tackled because it will be hard to do that, I would guess. But yeah, and that's kind of the end of the talk. Lucas shared a number of links in the chat, I think, earlier on. TypeScript is an amazing language, and if you haven't played with it, I highly recommend it to you. It's fun and it's highly type safe, which is a total seller for me. Thanks for listening to me, and yeah, thank you for your time.